Okay.
Okay, yes, we are live
All
now.
right. Okay, thank you, Doctor. All right. So I've been told that all of you are coming from computer science program, okay? And then I've been told also that you already learned about the basic using Python, okay, in your course. So today, the plan is I will share you, okay, one example of data set that you can use Python to do, for example, expiratory data analysis, okay, and then how you can apply machine learning using this data set in order for you to predict, okay, the output for a new data set. Okay, so we are going to utilize Python in data science. All right. So these are the contents for today. Okay, I'm using a breast cancer data set. All right. So imagine that you have different kind of data set, so you can relate, okay, in whatever that I will show you in a moment. Okay, on how, for example, if you want to do a prediction, okay, based on this data set, and also we will implement machine learning. Okay, as I said, to do a prediction for a new raw data that you have at hand. All right. So at the end of this sharing session, okay, you will know, okay, where to look for. Yeah, I think. Okay, you will know where to look for different database. All right, how you can import those database into your programming environment. Okay, and then you will able to do data preprocessing. All right, in terms of how you can do data cleaning. Okay, how you can do data modeling where you think that any column is unnecessary for your expiratory data analysis. Okay, so you can remove it. Okay, so that you can do a better data modeling at the end of the task. Okay, and then at the end of the day, you can see how you can do data prediction. All right, so these are the three main outcomes that you will expect to have at the end of this session. Okay, moving forward. All right, so basically what I will do, I will do a demonstration for you, okay, from scratch on how you can import this data set into one of the edited code that I will use in a moment. All right, so about this data set, okay, we want to predict, okay, whether this patient, okay, are having either benign or malignant cancer. Okay, so overall in cancer, there is two types of cancer where benign is not really, I can say that it's not really dangerous lah, okay, in terms of the recovery phase, and also in terms of the how this patient can live longer, okay, if they have benign. Okay, whereas for malignant, it's something like very dangerous cancer, okay, where it's very the cancer can spread in a short time. Okay, so it's about a life of a matter lah. Okay, so this breast cancer data set is coming from this guy here, Dr. William. Okay, he's a physician from University of Wisconsin Hospital in USA. All right. So actually in this data set, you will see 699 observation. Okay, so the database is collected on 15 July 1992. Okay, so on how this data set has been developed, okay, so it's based on the features that are computed from a digitalized image, okay, using this method here, FNA, fine needle aspirate, okay, of a breast mass. All right, so it describes the characteristic of cell nuclei present in the image. Okay, so based on this information that they have, okay, they come out with two class of cancer. Okay, one is benign, another is malignant. All right. So in this image also, okay, using 3D space, okay, they classify whether this patient is having benign or malignant based on this research paper here. Okay, you can look into it after this if you are interested. Okay, so robust linear programming discrimination of two linearly inseparable set. Okay, this is the name of the paper. All right. So you can find this database in this link here. All right. So if I click on this, okay. So this is the repository of this dataset, breast cancer with cousin. All right. So as I said here, there is 699 observation. Okay. We have 10 number of attributes, or you can call it features, or even you can call it columns. Okay. So you can see other information also lah from here. All right. If you have missing value or not in this data set, okay, see note here. Yes. Okay. And then the date of this raw data collection. Okay, from 15 July 1992. All right. So this is the guy name, Dr. William. Okay. So the information about the attribute that we have here. Okay. So one is the ID number. Okay, with respect to different patient that been diagnosed in this case. Okay, and then the second attribute is about clump thickness. Okay, so you can see here a scale, okay, from 1 to 10. All right, uniformity of the cell size from 1 to 10. Uniformity of the cell shape, okay, marginal addition and so on. All right, and then the last column here, the last attribute is about the class of this diagnosis. Okay, so you will see here two value, okay, 2 and 4. So 2 is represent the diagnosis as a benign cancer, okay, and then 4 is for malignant cancer. Okay, so you have a classification here in this data set. All right, and then so you can see like the relevant papers here if you want to know more about this data set. Okay, so where you can get the data. All right, so if you use this repository here, so you can see here download, and then you have data folder. Okay, so click on it. Okay, for example if you want to do this kind of data set. Okay, so these are the steps, okay, where you can look into the raw data itself. All right, so you can see here breast cancer with cousin.data. So this is actually the data, okay, the raw data. So okay, so moving on, so let's go into. Oh, okay, I didn't share you the sorry about that. Okay, I didn't share the desktop and okay. All right. So again, so this is the link where I got the data set, right? Breast cancer with cousin. And then to get the raw data itself, go to data folder. Okay, and this is the link to get the raw data, breast cancer with cousin.data. Okay, but before we go into this data set itself, okay, I want to show you what are the application, okay, that you can use to do this utilizing Python in data science. Okay, so one way is that you can install this application named Anaconda Navigator. All right, so in here you can see a few options for you to launch your editor code. Okay, so you need to use editor code to run your code. All right, so here I'm using a Jupyter notebook. Okay, once you download this Anaconda Navigator, and then you can see this interface here. All right, for example, if you want to use Jupyter notebook, so scroll down until you see this Jupyter notebook, and then press click on launch here. Okay, so once you launch your Jupyter notebook, it will open one browser. Okay, So by default, it will open Microsoft Edge. All right. So from here, you need to direct, okay, to your local directory where you keep this Jupyter notebook that you have. Okay, so for example, I have it in my desktop, and then all right, and then this is my Jupyter notebook. Okay, so you can use any other editor code that you want. Okay, you can use Spider, all right, and so on. Okay, so back to this data set here. Okay, I know this data set is really in deep about biological data set, and then all of you are coming from computer science, kan? Okay, maybe you have a conflict there, but I try to show you a different view about this kind of using Python in data science. Okay, so if you have any question, please let me know. All right, you can type in the chat box, and you can speak out through your mic. So at this moment, is there any question that you want to ask me? No? Everything okay? Can you follow me? All right. Okay. Okay. So I assume everything is okay lah. All right. So moving on. Okay. So here I'm using Python. Okay. In this Jupyter notebook. So Jupyter notebook is actually one of the open source. Okay, where you can do interactive programming. Okay, so you can have your code here, and then if you run it, it will give you the output. Okay, the execution right away. Okay, so it's interactive one. All right, so a bit about Jupyter notebook here. You can see on top here it's written on the right side. Okay, Python 3. Okay, so we are using Python 3 version. I think this is the latest version of Python. All right, and then this box here. Okay, so if I press one of this box here, this is, we call it cell. Okay, so in this cell, you can choose whether you want to write a code, or if you want to write just a text. Okay, it's not a code, something like this. Okay, breast cancer Wisconsin, how to do prediction. So this is not a code, it's just a text. Okay, so you can choose the mode for this cell as a markdown here. Okay, so this is the raw text that I write here using two hashtag here. So I want to write something like a title lah here. Okay, so it return me as a title. Okay, when I'm using the markdown mode. All right, and then if you want to write a code, and then you can change the mode into code. Okay, and then some more, if you want to add cell, you can press plus. Okay, you can change the position, okay, using the up and down arrow here. Okay, if you want to delete this cell, you can press on the scissor symbol here. Okay, and then if you want to save this Jupyter notebook, you can click on this floppy disk symbol. All right. Okay, so let's try. Okay, on this data set here. First, I'm using Pandas. Okay, one of the third library that you can import into this environment. Okay, so I import Pandas SPD so that I can use all the functionality in this library. Okay, to do this prediction for me. All right, so run the first cell here. Okay, so how we can import those data set from the link that I shared you just now, okay, in this environment. Okay, so you know where you can get the data, okay, the database, for example, in this case, okay, using this link here, and then you have the link directly towards the raw data itself, okay, the one that I just shown you. All right, so dot data, so this is the link. Okay, so using Pandas, we have this function here. Okay, read underscore CSV. Okay, then inside the round bracket, okay, you can specify the link that you want to use, or in fact, if you have the CSV or Excel file itself in your computer, so you can just right away use the local directory of that. Okay, and then we have I'm using argument here, okay, names, okay, to rename the column name that I have in this data set. Okay, so the first column is ID, second column is this one, third column this one, and so on. So I have a list of column names here, or attribute names here. Okay, and then the next code here is to return me the first 5 rows of this data set, okay, using head function. So at this stage, I have my data set in a data frame format. Okay, df here is my data frame format. Okay, you can choose any variable name that you want. Okay, as for me, I choose df. All right, so run it. So this is the first 5 rows observation. Okay, we have ID. ID should be unique. Okay, and then all the values inside respective attributes here. Okay, and then notice here the last attribute is about class. Okay, so as I mentioned before, there is only 2 values, 2 and 4. Okay, 2 is for benign, 4 is for malignant cancer. Okay, all right, do you have any questions so far? No? All good, yeah? All right. So the next part is how you can get the information, okay, about this data set using, again, Python. All right. So df is our data frame name. So .info, okay, it will return you the information on how many rows that you have. Okay, so 699. Okay, how many columns? Okay, you have 11 columns. Okay, and then some more, you can see whether you are having a missing value or not. Okay, so missing value, it return you as null value in your data point. So based on this, all the attribute has the maximum number of these entries. Okay, 699. So meaning that at this stage, you don't have any missing value. Okay, and then also you can see the data type for each of these attribute here. So for example, ID, the data type is integer. Okay, and then the only data type that is different here is this one. Okay, so it return you as a object. All right, so if you go back to this head of this data set here, so bare.nuclei here, so it's actually the same value, which is you have an integer here. Okay, it's actually is also a scale, okay, from 1 to 10. All right, but it written here as object. So object usually when you have like categorical variables. Okay, for example, gender, male and female. Okay, t-shirt size, okay, XL, SS, and so on. Okay, it's a categorical variables for object data type. All right, so at least at this stage, you can see, okay, this attribute is not correctly written you the right data type. Okay, we will see later on how you can change this into correct data type. Okay, so all right, so this is about using info function. Okay, so what you are doing here, okay, since from the start is first is to import the data set. Okay, and then now you start understanding your data set. It's very important for you. Okay, in data science, you need to really understand what kind of data set that you have at hand. Okay, what are the meaning of each attribute that you have? Okay, what are the value? And after that, only you know which one is quantitative variable and which one is categorical variables. Okay. Okay, so moving on. The next function here is called isNull. Okay, so isNull again is actually to check whether you have a missing value or not. Okay. So why I really emphasize on this missing value is that because if you have a missing value, okay, in your data point, okay, in any attribute, you can imagine that this missing value will give impact to your insight at the end of the day. Okay, so imagine if you have a lot of missing value in those rows. Okay, so maybe you want to consider whether you want to remove those rows, okay, or you need to impute those missing value with another value. Okay, so you need to handle this kind of missing value in your data set. That's why it's very important. Okay, before you do your expiratory data analysis, you need to clean your data first. Okay, so you need one of it to handle the missing value. All right, so df, again, the name of our data frame, dot isNull, dot sum, it will return you the numbers, okay, of missing value that you have in each attribute. Okay, so as I mentioned just now, based on this info function, you already know, okay, you don't have any missing value. So it's proven here lah. Okay, it's written you all 0. Okay, no missing value. All right, so just now, okay, I said about one of these attribute is not correctly written you the right data type. Okay, so one way you can use this function. All right, so pd.toNumeric, okay, it will casting, okay, this data type from object into a numerical data type. Okay, either it's float or integer. Okay, so do the changing on which attribute? Do only on this attribute. Okay, where nuclei. All right. So this is just another parameter. For example, if you click on, if you put your cursor after this function and then you press Shift tab, it actually will give you the documentation about this function. Okay, so by right, we are not going to memorize all those functions that exist, okay, using Python. Okay, it's impossible. It's a lot of function that you can use. Okay, so here you can see what this function can do is convert argument to a numeric type. And then what are the parameters that you can use in this function? So you can have a list of parameters here. Okay, so for example, the parameter for errors here, okay, by default is actually equal to raise. Okay, so whenever you have invalid value in this attribute, it will raise an exception. Okay, or it will raise you an error if you run this code. If you set the errors into raise, or you didn't put anything here, so it just run by default lah. Okay, so in this case, I set it the parameter into this, okay, so that if you have any invalid value in this attribute, it will set as none value, as a missing value. Okay, so maybe you are expecting that instead of having a scale from 1 to 10 in this attribute, maybe you have something else. Okay, so you want to denote this value as none value. So you can do something like this. Okay, so run this code here, and then again, if you check info of this data set, now instead of object, it changed into float. okay, for this attribute here. And then another thing that you can notice here, okay, non-null count here, it gives you 683, okay, out of 699 entries. Okay, so the rest of these rows here is actually you are having a missing value. Okay, so you can prove it by run this isNull function again, dot sum. So it return you, okay, this brand new client, you have 16 missing value. Okay, so as I said, you need to handle this missing value. So in this case, it's just a small number, right? Okay, it's just 16 out of 699 entries. Okay, maybe what you can do is just to remove these rows. Okay, remove these 16 rows from your data set. All right, so how you can do that? You can use drop null. Okay, so df.drop null, it will remove all the missing values that you have in these 16 rows. Okay, so run it, and then if you check again, isNull.sum, now you don't have any missing value. Okay, are you following me? All good? All right. So up until now, you already do data cleaning for this data set. Okay, maybe you can do more. Like for example, instead of float, you want to change it into integer. Okay, and then maybe you want to rename, okay, those column name. Okay, but at this stage, I only do this thing. Okay, drop the missing value. Okay, and then before you do your expiratory data analysis, okay, where you will look more, okay, and understanding more about each of these attributes that you have on how the distribution of this variable, okay, what are the relationship between benign and malignant cancer, all right. So you can execute a numerical summaries, okay, for all of these attribute. Okay, so you can use this function, describe function. Okay, so df dot describe, and then you can use this parameter include all. So meaning that you want to see all the numerical summaries in these attributes. Okay, 11 attributes. So it will return you these numerical summaries. Okay, what you have here, for each attribute, it return you the total number of the observation, okay, which is count. So after you remove the missing value, now it just return you 683 entries, okay, or observation. Okay, and then you can see the mean value, the average value for each of these attribute. Okay, for example, cell thickness 4.4, cell size 3.15, okay, and so on. All right, you can see the standard deviation, you can see the mean value, okay, the minimum value, okay, the smallest value for each of the attribute. You can see the 25 cutoff observation, okay, for example, at a 25% observation, okay, you have cell thickness of 2. Okay, this is how you can interpret this numerical summary. Okay, out of 100% of your observation, 25% of it has the value of cell thickness at the value of 2. Cell size is 1. Cell shape is 1. So if you want to see 50% observation, okay, what are the value of each attribute? So you can rely on these numerical summaries. At the 75% observation, okay, so this is something about doing a descriptive analysis of your data set. Okay, so 50% also is your median value. Okay, so you can compare. Do you have a similar value between median and also your mean value? Okay, so if you can see a wide gap between these two values, you can expect that you have an outlier in this attribute. So for example, side thickness, the average is 4.4 and then your median value is 4.0. Okay, it's not really a big difference. Okay, how about cell size? So cell size, the average is 3.15. Okay, and then the median is 1. Okay, so the difference is 2. Okay, about 2. So you can see if you plot the distribution plot, you can see whether you are having outliers, okay, whether your data is heavy on the right side or on the left side. Okay, we are talking about skewedness, or if you are having a normal distribution. Okay, and then lastly, you have the maximum value. Okay, the highest value that you have in these attributes here. Okay, so that's all the information that you can get from this described function. Okay, any questions so far? All right, so moving on. Okay, you can continue with expiratory data analysis. Okay, to see what is the category that you have. Okay, how many of them in each category, if you have a categorical variable. Okay, how is the distribution of your quantitative variable? And then for example, if you want to see whether you have a relationship, okay, between a pair of variables, okay, whether one value will increase if another value in your variable is increased. Okay, so you want to see a linear relationship, positive or negative, and so on. Okay, a lot of things that you can do in this EDA part. All right, so I'm going to show you part of it. Okay, a big part of it. So for visualization, okay, in Python, we will use Seaborn and Matplot library. Okay, so import Seaborn as SNS, and then you can import Matplot library as PLT. All right, so the next part here, I want to create, okay, I want to generate a heat map based on the data frame that I have. Okay, I want to check the correlation coefficient value. Okay, I want to see whether a pair of variables are having highly positive correlation or highly negative correlation. Okay, so you can do something like this. Okay, sns.heatmap. Okay, using this data frame.core. Okay, it will return you the correlation coefficient value. Okay, so by using heat map, you can have this hue. Okay, so on the right side here, you can see different hue. So the darker blue that you have a strongest positive correlation between the two quantitative variables. Okay, so as you can see here in the heat map, the diagonal area here, which is all denoted as 1 here, is actually the correlation between the same variables. Okay, that's why you are getting a perfect positive correlation here. Okay, correlation value. Okay, for example, the ID versus ID. Okay, it's written you 1 and so on. So what you want to see is the one below and or the one on top of this diagonal area here. Okay, it's just a mirror image. It's like a matrix lah, basically. Okay, the same thing, the one on top and the one below the diagonal area. So for example, if you look into the cell size, okay, versus okay, what I have here, cell shape, okay, cell shape versus cell size. Okay, you can see the value is 0.91. All right, so meaning that you have a strong positive correlation between these two quantitative variables. Okay, in other words, if you have a small cell shape, okay, you will also have a small cell size. Okay, and then yeah, oppositely, okay, if you have high value of cell shape, you will also have high value of cell size. Okay, because you have a strong positive correlation between these two. Okay, so if you have something like negative value here, it's close to -1, but we don't have here, right? Okay, if you have the value of close to 0, meaning that you don't have any correlation between those quantitative variables. Okay, all right. So if you have close to -1, meaning that you have a strong negative correlation. Okay, so in between, for example, above 0.5, okay, you can have a moderate, okay, positive, moderate, or you can say strong positive correlation, okay, from 0.5 until 1. Okay, and then by using this heat map, okay, right away you can see which one is having darker blue color here, okay, blue hue. So you can change if you don't like the bluish color here, you can change the hue here by using this parameter CMap. Okay. All right. So based on this, the more yellowish color that you have is denote a negative correlation. Okay. Any question? Okay, let's try on another code, okay, that you can use. For example, we are using SNS, okay, Seaborn, from Seaborn. You can use rel plot function, okay. So I try to create a line plot, okay, using two variables in this data set. Okay, for example, in this function, okay, you have X parameter, so you can specify the name of one variable here. For example, I choose okay, let me choose cell size. Okay, cell size for X parameter, and then for Y axis, okay, I want to use, okay, let's say marginal addition here. Okay, so the ultimate goal is I want to see whether we are having relationship or not between these two quantitative variables. Okay, so we can set the hue. Okay, another parameter here. Hue is based on we have class, okay, class benign and malignant. So in Python, exactly you need to use the same spelling because it's case sensitive. Okay, if it's in capital, so you need to write in capital. Okay. And then the kind of this plot, I want to create a line plot. Okay, and then this data is coming from my data frame, which is TF. All right, so let me run it. Okay, so you can see how easy that by using Python, okay, you can create a visualization. Okay, a line plot. So what you can see here is differentiate between the class. Again, you have class 2, class 4. Okay, 2 is benign, 4 is malignant. So you can see the relationship of this marginal addition versus cell size. Okay, overall for benign class, Okay, the value is lower than malignant. All right. Okay, so again, if you want to see the documentation of this function, so after you write your function name, okay, you can press Shift tab. Okay, then it will give you the list of, for example, the parameters that you can use. Okay, you can customize. Okay, for example, for kind parameter, okay, we go scroll down. For kind, where is kind? Okay, kind here. Okay, for rel plot, you can generate a scatter plot or you can create a line plot. Okay. All right. Okay. That's a bit part about visualization. Okay. Of course, you can do a lot more. Okay. By using different library if you want. Okay. So moving on. Okay, we want to go into data modeling. Okay, if you remember at the start of this sharing session, I told you about if you want to remove unnecessary column from your data set. Okay, because you think it didn't give you any importance of doing the EDA. Okay, so you can simply remove the column. So we call it data modeling. Okay, and then you can classify which one is your target feature. Okay, which one is your target variables. So in this case, okay, so let me run again. So this is our data frame, so df dot head, for example. Okay, or you can use tail if you want to see the last 5 rows in this data set. Okay, so these are the column that you have. So we know that ID, okay, it's not important in this analysis. Okay, you can simply remove it. All right. And in this case, okay, since we want to classify our target features, which is class, okay, we will create a new data frame. Okay, I call it cancer. So in this data frame, I want to have each of the attribute except for ID column and also the class column. Okay, so I can use this function drop. Okay, as this one, so it will do column wise, based on column wise. So run it. And now if you check your cancer data frame here, dot columns, it will return you the list of the columns that you have in cancer data frame. Okay, so it just return me these attributes. Okay, without having ID and also class. Okay, and then the next part, we create a Panda series. Okay, so because you only have one target features in this case, which is class. Okay, so cancer type is based on class. Okay, run it. So for example, if you want to do EDA on this cancer type Panda series, okay, you want to check the frequency of how many actually are classified as benign. Okay, how many are actually classified as malignant cancer. So you can use value underscore counts. Okay, on this Panda series cancer type. Okay, so it return you the frequency number. So majority of these data set are classified as benign. Okay, the value is 2. So the category is only 2, 2 and 4. Okay, and then the next is the frequency number. 444 for benign, 239 for malignant. Okay, and then instead of frequency number, you want to have a percentage value. Okay, so inside the value underscore counts function here, you can use parameter name normalize, equal to true. Okay, so whatever value that you have in each category, it will divide with the total number of observation that you have, and then times 100, okay, to get the percentage value. So for benign, it's about 65%, and then for malignant is about 35, okay, 35%. Okay, and then to have a clear view about this proportion, it's better for you maybe to generate a pie chart. Okay, so using this code here, okay, using value counts and then plot y, a pie chart for you, and then you can set this parameter. Okay, you can put the labeling, you can put the title, okay, you can set the position of the labeling, okay, and then show you the pie chart. So this is the pie chart. Okay, maybe you see that, okay, this is a long code here. How come I can memorize all of these things? So don't worry, okay? In programming, actually, we have a good supportive community, all right? So whenever you are considering to do something, okay, for example, using Python or any other programming language, okay, you just type in whatever concern that you have, and then you can see the solution of that. Okay, as long as you know what are the expected output that you want to see. Okay, so here it return you a pie chart. Okay, benign 65%, malignant 65%. Okay, are you still okay so far? Everything is okay? Any question, guys? No? All right, okay. Silence means everything is okay, I think. Okay, so yeah, let's continue. Okay, so for example, you want to determine the relationship between your target variable with your continuous or quantitative variables. Okay, so in Seaborn, you have this pair plot function. Okay, all right. So for example, let's say I give you one tips. Okay, so for example, if you already import your Seaborn package here, okay, Seaborn library in this environment. So when you write SNS dot and then press tab, okay, you will see this list of function actually, okay, that Seaborn has that you can use. Okay, so this is one of the shorthand that you can use to type in your code. Okay, for example, I'm using pair plot. Okay, so what is pair plot? So you can check the documentation. So okay, so pair plot is actually plot pairwise relationship in a data set. Okay, so it will create you like a grid frame, okay, of a scattered plot. In this case, is between your continuous variable, which is your x vars, versus your y variables, which is in this case is class. Okay, so run it. All right. So as you can see here, it return you a grid. Okay, a grid of scattered plot. So on the y-axis is the class. Okay, 2 and 4. Okay, and then on the x-axis you have a different continuous variables. So you can run at once for all the continuous variables. Amazing, right? Do you think it can save you a lot of time, okay, by using this Python code here, okay, to help you to generate this scattered plot for you, okay? So at this moment, okay, you can see, okay, whether you are having a relationship or not between these two class that you have. Okay, for example, cell thickness. Okay, for benign class, it's go up into scale 8. Okay, whereas for malignant, it goes up until scale 10. Okay, how about cell size? So cell size, you can see, okay, about the same scale. Okay, and then cell shape. Okay, and then for example, marginal addition here. Okay, between benign and malignant here, and the one below and the one on top, it's about the same scale. It just is missing scale 8 here. So by doing this pair plot or scatter plot here, it doesn't tell you much about the diagnosis. You cannot see a big difference on how the diagnosis is performed based on the scale value. Okay, since you can still see the maximum scale here in the benign class. Okay, you cannot say that, okay, if you have a marginal addition more than 6 scale, okay, meaning that you are having malignant cancer, not benign cancer. So at this stage, you cannot say that, since you have one data point here on the 10, the maximum scale on the benign class. Okay, same goes to the rest of the continuous variable. At least for marginal addition, epithelial cell size, okay, and then brain nuclei, you can still see the maximum scale here in your benign diagnose. Okay, so what you can do next, all right, in data science, you will do feature engineering. Okay, so feature engineering is actually you will do normalization into your data. Okay, so that you can improve the relationship between the target features and also the continuous variables that you have. Okay, so the main goal is you want to differentiate how you can diagnose whether this person is having benign or malignant cancer. Okay, so in feature engineering, in this case, I will do aggregation for all the continuous variables. Okay, I will create a data frame here, a new data frame, which I will aggregate all the value. Okay, so I will do summation for all the continuous variable that I have. Okay, so I will have column for called aggregate of all, and the second column is diagnosis. Okay, so the diagnosis is only class column, class attribute. Okay, the rest will go into aggregate of all. Okay, so here I'm actually creating a dictionary. Okay, I have key and value pairs. So in dictionary, you have a key and value pairs. So here the key is aggregate of all, and then another key is diagnosis. What are the value? Okay, these are the values. Okay, do the summation. Okay, return as a aggregate of all, and then for diagnose, only use the value from class. Okay, so I'm creating a new data frame here as a data underscore aggregate. What I have here, so you can use dot head, return you the first 5 rows. Okay, so you only have 2 columns, aggregate of all and diagnose. Okay, and then to normalize it, you can use this formula here. Okay, all right, so let me run this code. Okay, and then let's see the output of this normalization. All right, so here again you have 2 columns, aggregate of all and also diagnosis. Okay, So now you already did your feature engineering. Okay, let's see whether it can improve your visualization or not. Okay, so sns.scattered plot, this is another way lah on how you can create a scattered plot. Okay, you can use parameter data using this aggregate data. Okay, so on x-axis is the aggregate value, and then on y-axis is the class. Okay, so run it. So this is after you did feature engineering. Okay, did you agree if I said that this is much better compared to the previous output that you have here? Are you agree or not? Agree? Someone please. Are you agree?
Yes.
Yes, okay, finally I can hear some voices. So that I'm not alone. All right, good. Awesome, guys. Okay, so as you can see here, okay, on the y-axis is the diagnosis. Okay, diagnosis whether you have benign or malignant. Correct? So the one below here is benign, the one on top here is malignant. How I know that? Because of the value. Okay, 2 and 4. All right, and then on the x-axis is the value of aggregate of all, which I did the normalization, okay, for all the continuous variables. So you can see here, okay, for benign, okay, the value stop at, okay, generally lah, it stop at 0.4. Okay, of course you have something outliers here lah, okay, 1, 2, 3 data point here on benign. And then for malignant, okay, you can see it's up until 1.0. Okay, so at this stage, based on this visualization here, you can say that, okay, if you have aggregation of all value, okay, greater than 0.4, generally the cancer is classified as malignant cancer. Okay, now you can see obvious differentiation between the value of aggregation of all, okay, between these two classes. All right, that's how you can do your EDA, okay, by implement the feature engineering method here. Okay, all right, so actually as a data scientist, this is what your superior want to see. What are the insight, okay, that you can get from those expiratory data analysis that you did. Okay, if you refer to the previous pair plot here, okay, maybe everyone can do something like this. Okay, everyone can come up with this output here, the same output. Okay, but not everyone can do this feature engineering. Okay, so it gives big impact. Okay, at least by using this data set, you can see a big impact after you did feature engineering, okay, into your EDA. Okay, any question? Okay, so all right, so this is the ultimate goal that we want to perform in this data set. Okay, we want to use one of the artificial intelligence approach, okay, which is machine learning. Okay, so nowadays we are now actually in 4.0 revolution, industry revolution, right? Okay, so it's all about AI. So what is AI? So something that generally speaking, you want to automate things. Okay, you want to predict, okay, the future outcomes. Okay, you want to do some recommendation. For example, if you have a list of customers, okay, that buy your product, and then based on the behavior of this customer purchasing, okay, you want to recommend them into another product. All right, so you will use this AI approach. Okay, whether for example in this case I'm using a machine learning approach. Okay, so in general we have supervised machine learning, and also we have unsupervised machine learning. Okay, so in this data set I want to implement supervised machine learning. Okay, because we want to predict the outcomes of certain events. Okay, by using supervised machine learning, it will learn the relationship between the input and output, okay, through the classification that we have, okay, either benign or malignant cancer. And then when you have a new data come in, okay, imagine you have a new patient, okay, come in, and this patient is actually did all the tests, okay, in terms of all the attribute that we have just now, okay, and then how we can classify this new patient whether they are having benign or malignant cancer. Okay, so that's why we are using supervised machine learning here. Okay, so to measure if the model is good enough, you can use a method called train and test method. Okay, so by using this train and test method, you will measure the accuracy of your model. Okay, so in train and test method, okay, you will split your data set into two sets. One is a training set and another is testing set. Okay, the training set is used to create the model. Okay, imagine we will use a different model, okay, different algorithm, okay, to test the accuracy of this prediction. Okay, so we want to have the closest 100% accuracy between these different algorithm that we will run later on. Okay, so the test set is used to test the accuracy of the model. So that's why we have to split this data set into train and test. Okay, so how you can split it using this library here. Okay, you can import train test split. All right, so you can use your data frame just now. Okay, one is cancer and then another is cancer type. Okay, so just run it. I will not go through into each of these parameter here, but the main thing is to split your data set into train and test. Okay, and then you want to test a different model, okay, using the same set of data set, okay, so that you want to have the closest 100% accuracy, okay, to predict this, for example, new data in this data set. Okay, so once you split your data set, and then you can scale your data. Okay, so actually this scaling data is another big big topic, okay, that we can discuss, but we are not going to really go in deep into that. Okay, but overall this scaling data is used to minimize, okay, any bias in your data set. Okay, so how you can do that, for example, from this library here, you can import standard scaler. Okay, we will use this method to scale our data. Okay, we will transform on X train and then we will transform on X test, okay, respectively for X train and X test. Okay, this is how you do your scaling data. Okay, maybe it's a bit what can I say? A bit complicated for you to understand right now, okay, but just to get the main idea is that, okay, when you want to do machine learning, okay, these are the steps that you will do. Okay, start with split the data set, and then you will do data scaling. Okay, so that when you run your algorithm, okay, using different model, you will have the best accuracy. Okay, at least it can improve your accuracy value by using this scaling data. Okay, so moving on. All right, so this is one of the model that you can use to do your prediction. Okay, it's called logistic regression. Okay, so how you can use in this environment? Okay, again, you can import from this library here. Okay, and then using this method, you will fit on X train and Y train, and then for the Y prediction, you will use the X test. Okay, this is for logistic regression. So run it, and then this is the one that you want. Okay, you want to see the accuracy score. Okay, so using this library, import accuracy score, confusion metric, and classification report. Okay, first I will print the accuracy score. Okay, Y test and Y prediction. So I want to see what is the accuracy score. So by using logistic regression, okay, the accuracy of this prediction is about 96%. Okay, what I mean by that, so for example, if you have 100 records, okay, 103, by using logistic regression, it can predict 95 entry correctly. Okay, correctly between benign and malignant cancer. But the rest 4 entry are predicted wrongly. Okay, meaning that, for example, that patient supposedly having benign cancer, but it's been predicted of having malignant cancer. Okay, so the error here by using logistic regression is said to be 4%. Okay, 4% error. All right. So by using accuracy score, we cannot predict what type of error that we are having right now. Okay, this 4% error. But in general, there are 2 types of error. Okay, type 1 and type 2. So type 1 said that for malignant cancer patient, okay, they are predicted as benign cancer. That is type 1. Okay, supposedly this patient having malignant but is predicted benign. Okay, and then type 2, this patient is having benign cancer, but he or she is predicted having malignant cancer. Okay, so what do you think? Which one is more crucial when we are talking about breast cancer dataset? Which error is more important? Is it type 1 or type 2? Okay, can you type in the chat box? Which one that you vote? We are talking about cancer dataset. Guys, what is your thought? Which one is more crucial? Which one is more important? Is it type 1 or type 2? Guys, are you here? Are you shy? Are you afraid of giving me the wrong answer? Okay, so it's like this. Okay, so it depends on which kind of data set that you are dealing with. Okay, so in this case, when we said about cancer data type, okay, cancer data set, So it's actually, okay, which one that you think is more important? So it's actually, okay, imagine when someone has cancer, okay, they are having malignant cancer, all right? And if the model that you use predict this guy as a benign cancer, okay, so this guy are not getting the right treatment, okay. For example, they don't go through the chemotherapy or radiotherapy and things like that because they has been diagnosed as a benign cancer. Okay, so in cancer dataset is actually type 1 is more important. Okay, because we are actually dealing with the life of your patient. Okay, at some point if they gone through the treatment, at least, okay, maybe they can you know, they can remove all the cancer cell that they have in their body, okay, or maybe it's help them to live longer. Okay, so that's why I said, okay, type 1 is more important in this case. All right, so in machine learning, okay, if you are using the confusion metric, all right, it will help you to summarize the performance of this classification. Okay, you will know how many of them are having the right prediction, okay, how many of them are getting type 1 or type 2 error. Okay, so in this case, since we already run the model using logistic regression just now, okay, so we can use y-test and y-pred here on this confusion metric, okay, that we import earlier using as scikit-learn here dot matrix. Okay, so as you can see here, you import accuracy score, confusion metric, and classification report. Okay, so just call confusion metric here. Okay, this function, so run it. So you have a matrix here as the output. Okay, like a 2D dimension array. Okay, so you have 4 value 1, 0, 6, 5, 2, and 58. So how you can interpret this? Okay, refer to this diagram here. All right, so this is how you can relate, okay, the value here with this diagram. Okay, for example, the one on the left side, the most left side on top is actually represent true positive, okay, TP, meaning that the actual value is benign. Okay, this patient is actually having benign cancer, and by using logistic regression, you are predicting true. Yes, this person is having benign. So how many of them? 106. Okay, and then true negative. True negative, the one on the right side at the bottom, okay, 58 is denoted for true negative, is represent true negative, TN. Okay, so in this case, it's represent, okay, 58% of this patient is having malignant cancer, and then you predicted is as a malignant cancer. Okay, true negative. And then how many type 1 error? Okay, how many malignant cancer that you are predicting, predicted the value wrongly using logistic regression is 2. Okay, 2 is type 1 error. Okay, this person is actually having malignant cancer, but is predicted as a benign cancer. 2 out of 600. 600 berapa tadi? How many of them in total? Okay, 600 something. I can't recall it. Okay. All right. So that's how you predict this confusion metric. Okay, and then 5. This person is having actually benign cancer, but they are predicted as a malignant cancer. Okay, so you have type 2 error on the right side on top. Okay. All right. All right. Okay, so this is remember this one is actually after you did your train and test splitting. Okay, so you are not getting the total number of 600 something that we have earlier in the raw data. Okay, but it's actually already splitting into this value here. Okay, so how about classification report? Okay, so classification report, if you run it, okay, you can see the value of precision, recall, F1, and support. Okay, so this information actually giving you different interpretation. Okay, for example, okay, see that we are dealing with cancer data set. Okay, I can say recall value is more important. You need to rely on the recall value. Okay, why I said that? Because recall value here is a measure how many positive your model is able to recall from the data. Okay, how many of them are having benign and how many of them are having malignant cancer. Okay, and then for precision is telling you the ratio of correct positive prediction to the total positive prediction. So for example, if we have a different data set, maybe about to classify whether we are having spam email or not. Okay, in this case, maybe you want to prioritize on the precision value. Okay, because you want to have a higher accuracy value, okay, in order to classify your spam email. Okay, but in this data set, okay, cancer data set, recall is more important. Okay, all right, because in cancer prediction, okay, if the model predict cancer record as non-cancer, okay, like we have in error 1, meaning that it's too risky for your patient. Okay, all the cancer record, which is the malignant, should be predicted correctly. Okay, that's why recall is more important. Okay, so after this, if you want to compare between different algorithm, you will prioritize on this recall on class 4 value. Okay, at this moment is 97%. Okay, and then F1 score, it deal with false positive and false negative. Okay, for some models, you also want to know the distribution of false negative and false positive. So maybe for that, you can use F1 score. Okay, to evaluate the performance of the model. All right, so back to the machine learning. Okay, so now I want to use another algorithm, okay, another method in supervised machine learning, which is decision tree, okay, to check whether if I'm having a better accuracy or not, okay, in the recall value. Okay, so the same thing, okay, just you need to import this method, okay, from scikit-learn.tree and so on. Okay, feed on train and then predict on test. Okay, first is to check the accuracy score. So by using decision tree is 0.96, about 96% again. Okay, the same that what you get using logistic regression. And then confusion matrix. Yeah, you can see improvement here. Okay, only one malignant cancer is predicted wrongly as a benign. Okay, and then based on the classification report, okay, the recall also improved. Okay, 0.998 in decision tree, while in logistic is 0.97. and 97%. This one 98%. Okay, how about using another method, which is Naive-Bayes? Okay, so this is the accuracy score, 96. Confusion metric, the same what you get in logistic regression. And then recall also the same. And then lastly, support vector machine. Again, this is another algorithm. Okay, so the accuracy is 96. This one, yeah, confusion metric. Okay, again, only one malignant cancer has been predicted as benign. Classification report, recall is 0.98. Okay, so by comparing these four methods here, okay, for algorithm, the best one is SVM and also decision tree. Okay, but still you cannot do like 100% prediction, okay, correct accuracy. Someone is still predicted wrongly. Okay, so actually we have a lot of method here, okay, a lot of algorithm. In fact, you can use a parameter that can improve the prediction of this modeling. Okay, so this is just part of it lah. Okay, so yeah, that's all on how you can utilize Python by using breast cancer data set. Okay, back to my presentation just now. Okay, let me open back the presentation. Okay, so I already shown you, okay, step by step on how you can use Python, okay, in data science. So for the summary, okay, this data set is actually, it's very old lah. All right, you already seen on it's actually like 20 years ago data set. Okay, so however, it's allowed you to create a simple model, and then you can use various machine learning method. Okay, so at the moment, support vector machine and also decision tree is the best prediction model, again with the accuracy of 68% and the recall value of 68%. Okay, so like I said, you can improve the model. Okay, for example, you can use research CV library. Okay, in the sense that you can tune in the hyperparameter. Okay, in this modeling so that you can get better prediction model. Okay, the best one is of course 100%. Okay, so this approach, okay, is actually very important. Okay, as a machine learning has a greater and greater role in, for example, in healthcare. Yeah, not even in healthcare. For example, if you involved in purchasing, okay, in banking, so you can of course you can implement, okay, Python, okay, in doing your data science tasks. Okay, all right, that's all from me. Okay, all right, do you have any question? I'm seeing yeah, okay,
no question.
no question. Surprisingly, okay, so I know that you are on your third semester, right? Is it third semester, second year?
Yes.
Yeah, okay, long way to go in your courses, okay, before your graduation, but actually this is the best time, okay, where you can get exposure on different kind of implementation. Okay, say if you want to use Python, okay, or if you want to use other programming language like R or C++, Java, and so on. Okay, so this is one of the implementation that you can use. Okay,
Okay.
alright. Okay, the rest of you? No? Is Dr. Prasanna here? Okay, I think she need to attend the meeting with your VC, so that's okay. Okay, let's see. If you want to know more about, you want to self-learn about data science especially, okay. So in CATS, actually we have a platform, all right, where you can, it's a free platform where you can log in, okay, and then let me run through it, okay. Where is it? Okay, so let me share back my screen here. So it's called cats.ai. Okay, this one is our new product actually, okay, in CATS. So if you go sign up into this link here, okay, I shared in the chat box for the link. So for example, I'm using mine. Okay, so this is the home page. All right, so you can fill in your profile here. You can claim any skill that you have, okay, and then based on the skill that you claim here, you can try to do a quiz, okay, so that you can know at which level are you. Okay, for example, I didn't do this quiz yet, but yeah, you can try on it. Okay, so by default it will return you as level 1, okay, and then by progress, if you did the quiz, and then it will give you level 3 and so on. Okay, so besides that, okay, for example, if you look into the left side here, we have different tools here. If you press on learning, okay, based on the skill that you claimed before, okay, it will suggest you the learning path that you can try. It is a free. Okay, for example, associate enterprise data analyst. If you click on it, okay, this is the one that has been suggested to me to attend. Okay, so in case we have this AADA learning path, all right, but you can try. Okay, for example, Python for analytic basic. Okay, you press on it. So we provide you like free online self-learning here. Okay, coming from different sources like YouTube or Coursera. So we are helping you, okay, so that you can learn by yourself, okay, through these courses. Okay, it kind of interesting, right? Okay, so basically it's guide you lah what you can do in order for you to upskilling, okay, in order to you to choose your career later on. All right, okay, and then opportunities here, okay, of course you can, when you do after your graduation, okay, you can have here lah the job that match your skill. Okay, all right, so yeah, if you want, you can try log in, okay, sign up to this link here. Okay, I think if you don't have any question, I will end the session now. Okay, I wish you all the best, okay, in your future undertaking. Okay, so yeah, that's all from me.
Thank you.
Okay, guys. Okay, thank you so much.
Thank you.
Okay, all right.
Thank you.
If you want to ask me anything after this, okay, you can find me in LinkedIn. Okay, all right.
Okay.
Okay. Thank you, guys. Assalamualaikum.
Waalaikumsalam. Thank you so much.
Okay, welcome.